go. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so my name is AMSYAR based at WAHID, and with my partner Ahmad Firdaus, we will going to explain what we do in lab 3. Okay, so first for part 1, design network subnetting scheme. Okay, create a subnetting scheme that means required number of subnet and required number of host address. So here the scheme. The first subnet is the employee network, minimum 25 host IP address. Second subnet, administration network, minimum 10 IP address. Third and fourth subnet, reserve virtual network interface, loop 0 loopback, okay. And also two additional unused subnet for future network expansion. Okay, so here the scheme. And then for the answer the question. Okay, how many host address are need in the largest required subnet? 25. Because here the ni we need minimum 25 host IP address, and then minimum number of subnets required. Okay, so for the subnet here, first subnet, second, third and fourth, and also need two additional unused subnet, which is so the total is C. Okay, and then the number 3, what is the 24 subnet mask in binary? Okay, so when we convert it, we get like this 1 8 times 1 and 0 0 0. Okay, and then the subnet mask is made up of two portion. The portion is okay. So in the network mask, what do the ones represent? Okay, for the one we that represent is network portion, and the zeros represent host portion. Okay, and then for the number 5, okay, total decimal number subnet mask equivalent. Okay, for 35, number of subnet, we get 2 power of 1 because the subnet is 1 here. We can see that 1 and then equal to 2. And then number of hosts is 7 because total is 8 and then minus 1, which is the subnet, we get the 7 the host. And then the formula 2 power of 7, don't forget also we need to minus 2, which is equal to 126 hosts per subnet, and so on with the 26, 27, 28. Okay, and then for the question number 6, considering your answer, which subnet must meet the required number of minimum host address? Okay, so for the subnet must meet the required number of minimum host address. Okay, for the minimum, we look back, we need required 25 subnet, and then we can see that for the subnet 125, 26 and 27 meet the requirement 25. For the others subnet mask 14 hosts, which is not enough the minimum required host. And then the which subnet mask meet the minimum number of subnet mask required 27, 28, 29, 30. Minimum number of subnet required. Okay, and then for the number 8, consider your answer, which subnet must need the required minimum number of hosts and minimum number of subnet required, and then 27. Because we need the minimum host 25, and then the subnet is 6. Okay, and then number 9, we know that from the first subnet is 122.168.0.0. Okay, from this first subnet we can derive to get the for the other subnet. And then we know that the prefix is 27, the subnet mask. And then from this IP address, I use the IP calculator to find the subnet mask. Okay, and then we get the subnet mask 25. 255, 255, 255, and 224. Okay. And then for the step 2, okay, we need to fill in the IP address and subnet mask in the slash prefiguration. Okay, so we can choose for the for suitable IP address and subnet mask for this slash prefiguration for this network. And then here the IP address and the subnet mask and the default gateway. Okay, for part 2, configure the devices. Okay, first we need to set up all of it, the IP configuration for the PC and PCB. Okay, and then configure the router. Okay, configure the router like this. Okay, okay. So enter previous set mode and global config mode. This just like that 1 and 2, we just uh, just doing the same thing. And then step 1 config, and step 2 configure the PC interface. Configure the subnet default gateway setting in the router. And then for part 3, after done with the configuration, we need to test and troubleshoot the network. Okay. Test to see if PCA can communicate with its default gateway. From PCA, open a command prompt and ping the IP address of the router gigabit internet 0.1 interface. Okay. From PCA, we need to ping the IP address of the router gigabit internet 01. So here 01. So we need to fill the IP address for the router, which is 192.168 and 033. Okay, just right here. And then we get the result. Packet send for, receive for. So do you get reply? Yes. Okay. Same also with the B. We need to from PCB open a command prompt and ping the IP address of the router gigabit internet from 00 interface, which is this ping, this IP address. Do you get a reply? Yes, we get the reply here. And also test to see if PCA can communicate with PCB. From PCA, open a command prompt and ping the IP address of PCB. Okay, so here the ping of the PCB, IP address for the PCB, and then we get the reply. Send for, receive for. Yes. Okay, for E, sebenarnya by purpose majority PC address of PCA. What happen when you try and ping from PCA? Do you receive a reply? Okay, so what happen when you try and ping them for PCA to PCB to PCA? It show that the packet are lost and we do not receive any reply because the gateway for the PCA is not 10001, but uh, uh, but the PCA, what happened with the PCA? Okay, because the gateway for the PCB is this 192 and 168.01. Okay, for part 4, my Ahmad Firdaus will continue to explain it.
All right, next is part 4. We are going to design the VLSN address scheme, and the requirement is the same as the part 1, which is we need 25 host IP address for the employee network, 10 IP address minimum for the second subnet, which is the administration network, and for the third and fourth subnet are reserved as virtual networks on virtual router interfaces. look back 0 and look back 1. Alright, and then we're gonna need unused subnet for future network expansion, and each subnet you need a minimum of 4 host IP address. Alright, for the step 1, we have to calculate the subnet information. Okay, as you can see in the first data, employee network number of hosts required is 25. So the number of host bits is 5 because the number of hosts is 30. The formula given is the 2 power of h minus 2, which is h is the host bits. The same requiring for the it's not the same, and for the next administration network, which is we're gonna have the number of hosts required is 10, the number of host bit is 4, and the number of hosts gonna be 14. For the virtual network 1 and 2, the number of hosts required is 5, number of host bit is 3, and number of hosts is 6. And for the next remaining other two, which is future network 1 and 2, number of hosts required is 4, number of host bits is 3, and number of hosts is 6. For the subnet mask for the data 1 is /227, or subnet mask 224 at the back, and for the second one is /28 or 240 at the back, and for the remaining four, which one network 1 until the future network 2 is /29 or 248 at the back. And for the second table, we just take from the part 1 table and just put in, which is for the first host address, we just plus 1 from the network address, and for the last host address, we're gonna plus 30 from the first host address and minus 1, and for the broadcast address, we just plus 1 from the last host address. The same step we made on each and every of the data, which is 1, 2, 3, 4, 5, 6 data. Okay, next for the step 2. This is the topology for the part 4, which is the same as the part 1, and the addressing table also the same. The IP address, the subnet mask, and the default gateway also the same. Net is the step 3. Cable the network as shown in the topology. Okay, step 4, step 5. We just made the same step from the part 1. Okay, next for the step 6. After that, we're gonna test the connectivity, and yes, as you can see, each and every of the test connectivity and troubleshoot we made is all were sent for, received for, which is 100% no loss. Okay, next for the, and then the troubleshoot connectivity issues if ping were not successful. Every connectivity that we made and the troubleshoot has no ping not successful. All were successful.
Yes.
that's all from us. Thank you.
Thank you.